to write simple programs. So the objective is to know the steps in orderly format to develop the software. Okay, so we would go into the software design life cycle. Software design life cycle is actually in computer science is an important term. It's called software development life cycle. Software development life cycle. Okay, and this one actually in UC Irvine, they have a department called informatics. There is a department called statistics. There is another one called computer science. These three departments together form a school called information and informatics and computer science. Okay, so these three things actually is a school. It's not like other school have a school of engineering. They have a school of informatics and computer science. So informatics itself is a big department. And in the old days, this department is called software engineering. In the old days, it's called software engineering. So software engineering is in charge of developing software.
Informatics 中文是什么？
它这个叫做现在 no Chinese translation actually.
哦，哇，我不是很懂。
It's quite new, okay? Okay, to be short, you just try to understand it is actually a software engineering. And software engineering is, as I defined before, any engineering discipline is to build. So actually it's a engineering discipline to build softwares.
Okay.
So that actually teach you how to build a software, okay? So basically informatics is somewhat, in the old days, it actually is a department under software engineering. So software engineering actually including a few things. It's actually in charge of the software development from analysis to design to implementation to testing. Okay, so it's actually this is called software design life cycle, right? So software engineering basically in charge of how you step by step to develop a software, right? So some of the tool developed by you is actually say in your design or in your implementation, you might need to design user interface, graphic user interface, or you need to design a better user experience. User experience, UX means user experience. So GUI and the user experience becomes something called informatics. So you might heard something called bioinformatics. Well, what is bioinformatics? It's something like say we have some fingerprint. Right? So from some fingerprint, actually it going to some scanner.
Yes.
And the scanner will recognize who the person is. Surely it will be identified by the fingerprint. So from the interface, taking the picture for some print up to the computation and get the result to recognize a person is called informatics.
Okay.
Getting information from user interface. So that's what informatics really means. But in terms of Mandarin or Chinese, I don't know. I don't know what this should be translated. And so far, I haven't heard of any Chinese word describing this yet. Okay, so basically it's like you may learn some new words, say analytics. And this new word called informatics. It's the same thing. It's the same thing. Some sort of a program that help you to collect information is called informatics. Some sort of a program to help you to do analysis is called analytics. So informatics is some program that help you to collect the information.
Yeah.
So sampling information, bioinformatics, help you to collect the bio data. Iris, iris, this is iris, okay, in your eye. Iris recognition. That's also bioinformatics. So some of the ICS things actually is a program. And it actually helps you to actually collect informatics, collect the information from your bio feature. Okay, so informatics in a way is a new idea, it's a newer name and gain more fashion, but the department actually really is working on some old discipline. It's called software development or software engineering to build softwares. So this chapter we actually try to give you some basic idea of how actually to help you to understand what is the software engineering and how to develop a program. But in a way, in the center we have computer science, right? And we have outer space that actually is collecting information for the program, right? And in the real kernel, something, as I said, there is a math inside computer science to drive everything, right? And statistics is one of the main core concepts. So this ICS department in Irvine actually is organized in a way to do the whole thing.
Okay.
That's why Irvine has a separate computer science and informatics department at a school. That's not even a computer engineering school. So basically right here we actually try to understand the program by writing from input, processing, and output. Is called IPO process. So you have a processing unit.
IPO, okay.
Processing unit, you have input, and you create something to output. Okay? And then to understand how the duo is valid Python identifier and expression. Okay? So now let's get started for this one. And then to be able to understand how to write Python statements to the output information to the screen, assign value to variables, get numerical information from keyboard or whatever. So it basically deal with a basic idea of how to get data from the outside and then how to process it and how to provide to your monitor. Okay, so now let's look at the software development. So software development actually is this software design lifecycle. Okay, this whole thing is called software development lifecycle, from analysis, requirement, design, implementation, and then testing, and then maintenance. Okay.
Okay.
The first step, say I have a requirement of, say now I have a program. I need to convert my my kilogram to my pounds, right? That's my, I want to write a program for this. So that I need to analyze what I need to do, right? So basically, I need to have a formula that actually, I need to read in some data from keyboard, right? And that data, say I get a data called K, and then this K need to times what? 2.05. That will become my pound, right?
Yeah.
K number is smaller, pound is bigger, right? So I actually get the number of pounds over here, and then I output to my output. So this thing actually is more like analysis. What need to be done by my program, and what information I need to get, what information I need to provide. So this is actually more or less like user interface and program feasibility. Is this doable by my, is it really doable by my program or not? Okay. And then I need to do analysis. Okay, I need to do this calculation. Sometimes the calculation may be too big and then it's not feasible. Or not something, you give me $3 million and I cannot finish it. If it is possible, so here actually will be back and forth to argue about the budget sometimes. Okay, until you finish a spec. Okay, and the spec becomes the contract between your customer and the engineering team. Okay, once the contract is firm, then you go into design. So we break down the software piece by piece, right? And then who responsible for what. At that time, you hand over a certain block to assign to some manager or engineers to do that. That becomes implementation stage. And after that, each engineer finish its own block. Then we start to test the data, whether this block talk to that block is okay or not. That's testing. And you finish testing, then you actually operate it and then send out and release the product, go to the market. And then you have the alpha test, the beta test. The alpha test is the inside testing. Beta test is outside testing.
Oh, okay.
Beta test usually is like Microsoft Windows beta version, and some people download from website. Alpha test is in-house. You ask a few engineers to help you to do testing. So this whole discipline is called software engineering, and we call it software development lifecycle. But this is only one of the model, and this model you see right here, step by step, going down like this, is called waterfall model. It's somewhat like a Niagara Falls, okay, the waterfall model. And there are several different models. This is one of them. So then the first one is we need to analyze problem, figure out exactly what problem to be solved, understanding it as much as possible, set out a project goal, budgeting, feasibility study. Second one is to determine the specification. Basically, this spec is the contract between the customer and your company. Okay, so describe exactly what your program will do and then what you can provide for the customer. So don't worry about how the program works. How it works is belong to the engineer. So here is actually more like a business talk. So including describing the input output. Okay, that customer need the input and need that output, and then you relate it to another. Okay, so the next one is design. So once the contract between the customer and the company is firm, then we formulate the overall structure of the program and then break down into pieces and then allow the engineer to take over those pieces. So this stage is called design. And then after the design, we assign each block to a certain engineer and pick some programming language to realize it. And then that is called the implementation. So in this course, we use only Python, but in some case, you may have mixed environment or have multiple languages. Then after that, you test and debug the program, try out your program to see whether it works or not. If there are errors, then we need to fix it. Or maybe the design is wrong. We go back to the design state to change the design. Okay, so your goal is to find the errors and keep trying to break the program. So after that, we release for testing, alpha testing, asking the inside people to test it, and then outside people for beta version, and then we release the product. After we release the product, it becomes the maintenance and operation stage. So user use it, they may be complaint, sample the complaint, and then we update our software as a maintenance stage. So that waterfall model later is changed to this one called V model. V model is similar to waterfall model, except that we from a concept to a big system to subsystem to smaller system to unit. And then when we testing, we go back from small unit testing to a subsystem testing, and then system testing to gradually test from smaller one to bigger one until customer accept it. So this acceptance test actually beta test. So this V model is a updated version of the waterfall model.
Oh, okay.
Okay. So example program, if we have a converter, say we need to convert from Celsius to Fahrenheit. Okay, so our input is Celsius temperature, and then output is Fahrenheit, and then the input times 1.8 plus 32 will become the output, right? So we know the input, output requirement, and the process. and then we actually process it to convert to Fahrenheit like this, okay? And then the output result by the displaying it on the screen, okay? Like that. So let's drop the program in pseudocode, okay? So pseudocode is something you use in English to write it, okay? So basically, what is a pseudocode? Pseudocode is quite easy. So before we actually write a program in Python, actually we can write some pseudocode. So the pseudocode is something like this. We basically is called like Celsius coming from keyboard, right? And then Celsius times 1.8 plus 32. You assign to your Fahrenheit, right? And then the next one you print Fahrenheit. So use very simple English to describe your program. And then you convert the pseudocode into your Python. But nowadays, actually, I encourage my student to use the Python as a pseudocode because it's quite easy already.
Oh, okay.
Okay, I encourage the student to use the Python for pseudocode. So so then you have a pseudocode and then you convert it to Python. So this is a program for Python, right? So your function, like there's a user, and then you type in something, and then you process it and actually print out to monitor, okay? And then you can also test the program on your command line, okay? So right here, actually, is a few functions you need to learn. Is like you have a expression, you can actually convert it to floor. So these are the type converter, okay? So before we go into that type converter things, let's try a sample. So right here, let's see. Check two is a convert function. Before we run this convert function, let me actually new a program, okay? So this one called okay. So this one is sudo.py. So for pseudocode. So before you develop software, maybe you can do this. You can say this one called. Usually you can do like sudo.py a program, right? And then you say like this one name. So like Sherry Queen, right? And then you need to have date, okay? So that one is like 10/11/2018, right? And then installation. It's like this one, for example, my machine is like HP, whatever, MV, like 3000. I don't remember the name, but let's do it like and then say Windows 10. Okay, knowing about in version and then version 3.2. Okay, here just trying to show you like normally how people document their program, but as a beginner, you don't need this, okay? I just show you usually what is the header. Okay, after that, I would say like the input, okay, step by step print my program, processing, okay, and then output, okay. Okay, after that, I say my C equals my input, okay. So actually it should be input, okay. And then here I should say enter temperature in Celsius. Am I correct? Am I spelling it right? It's S, not C. Okay. So that input, but this after this input, this data C actually is a string. Okay, it's not integer. So right here, I need to convert it to a integer. So basically, in Python, you will have three types of data. You have three types of data. Basically, Python only has three types of data. One type is called number. Number divided to integer and the floating point number. Okay, so floating point number is like 3.2 is floating, the real number. And then the other type integer is like 1, 2, 3. 1, 2, 3, those type of integer. And the second type is called Boolean. So Boolean only have trues and false.
Oh, okay.
Correct or not correct, okay?
Right.
Third type is called string. String is like A, B, C, those are text. But usually you have a single quote, double quote, or triple quote. It all considered to be a string. Okay? There is no character. There is no character type in Python. No character type in Python. So here basically I need to convert this one from the input. Actually, it actually will get data into string format, and then need to convert it to this one called integer. Okay, so I get the Celsius data. The second stage, I say my Fahrenheit equals my Celsius. Okay, my Celsius data times 1.8 plus 32. So when I time 1.8, the number already converted to 14 point. So eventually this F will be 14 point number. Okay, and then my output will be, my output should be print F.
Yeah.
So like 32 you should get, I mean 0 you should get 32. Right? And then if we have 90, say Celsius, if we have 37, but body temperature, it should be around 100, right? 98 or something. Okay? So that actually is the converter, simple converter. But this one, we pretty much write it without any documentation or format. So that can be considered as a pseudocode. Pseudocode. So the real version you may write into this. So you have main program, and then you actually run the main program and then put into call a function. So this function is called by this main function, and then you actually do ask for the temperature and convert it. Okay, so let's run this one. Okay, same thing. You type in 0, it should give you 32 degrees. Okay.
Okay.
So this actually is a program including the input to output. Okay, but here it uses eval instead of integer. Okay. So here we have, say this table we have 4 functions.
Okay.
Okay. Here we have 4 functions. Okay. Here we have 4 functions. We can convert a string to integer, convert a string to floating point. We can convert an integer to string. And this eval usually is like you put a string in there, it can eval to either floating point or integer, depending on which number it is. So basically, let me try here to new something called eval. Okay, let's look at this eval module. So here I can print. I'm sorry. I say I equals integer 3.5. Okay, let's try this one. Okay. I try to convert 3.5 to integer, so it's invalid literal. So, but if I actually put 3 as a string, it should pass. Okay, it should pass for integer. So here, if I say f equals float, and say 3.5, okay? This one's okay, right? And then float 2 equals float. Three again. It's still okay, right?
Mm-hmm.
And then this one say E equals eval of 3. And then I say print type of E. Okay, and I have E2 equals eval 3.3 print type of E2. You see, the E and E2 got evolved into different class. So E actually is 3 evolved to integer class. And 3.3 evolved to 40. So eval actually can convert a number into either integer or floating point. But integer always convert to integer. Floating point can convert to both converting to floating point, but floating point you can convert a 3 integer format into a floating point. Is that okay?
Okay. So I always use eval.
No, actually either way. Nowadays people don't actually prefer to use eval. So basically you have 3, you can convert to integer by integer, right? 3.5, you can convert to some f, right? And also you can use like float to convert it. Right? And then actually you convert it to a E2 by eval, right? You convert it to a E2 E by eval. You know what I'm saying? That's the whatever conversion we have achieved right here. It's more or less. The integer can only convert a integer literal into integer. Floating point can convert a integer to floating point or a floating point into floating point. Okay, and then eval convert integer to integer, floating point to floating point string. Okay.
Okay.
Let me know when you are done with the writing. Okay.
How?
Okay. And let's continue. Okay. So that part actually is the conversion of data type. And basically, I mentioned there are 4 data types in our system. So the next one is actually the element of the program. Yes.
等一下，我刚刚那个，我还是觉得，我就是写程式的时候都用 eval 就好了。为什么你说 eval 没有很多人不常用？
Because if your program get bigger, you forget whether it's an integer or a floating point.
But eval including integer and
it will make people confused whether it's an integer or a floating point.
But if you want the people input some numbers, but you don't know the numbers is integer or
it's always a float. So because Python has no declaration, it's not like C or C++ or Java. You need to declare the type of the data. So if there is a declaration, it's more clear. But Python actually have nothing like that. So when the program get bigger or you debug other people's program, it's easy to create trouble.
Okay.
It's easier to create trouble because the other programmer may not know, okay, this guy put eval everywhere, and I really don't know whether it's an integer or it's a floating point number.
Okay.
So that actually sometimes create confusion and then create trouble.
Okay.
So it's like team issue sometimes.
Okay.
For example, you write program for yourself. I don't think that is a big issue. No.
Okay.
You know what you are doing, right? And then even yourself, maybe 10 years later, you forget it. or some long time later you forget.
Okay.
Okay. So the program, actually Python program consists of module, statement, expression, object. So your program consists of module, statement, expression, object. Okay. So let's look at the Python program. Okay. So here say I have these different things. Let me actually create something called here. Let me say Python file. So here, let me see. Here is like temperature. Let me call something called temperature. Okay, so I have defined a function called Celsius2 Fahrenheit. Okay, so I get some variable called C, right? And then I need to convert Fahrenheit, so I return C times 1.8 plus 32, right? And I define something called Fahrenheit to Celsius and enter F and return F minus 32 and divided by 1.8, right? So this temperature that py only do this thing, right? And then here I have some program called test temp, okay, test temperature. So inside here I actually do this from temperature import and start.
Start is means import anything. Okay.
Everything, okay? So here I can say like, okay, T1, okay, let me do this. Okay. So this one means like I have a for loop. My T starting from 0 to 110. Each time increase by 10, okay?
Oh.
So now actually first I just print T, okay? Before I run anything about temperature, let's do this.
Okay.
So I actually created all the number from 0 to 10, right? The next thing is like, okay, I got this. I can comment this guy out, right? And then I say this is the Celsius temperature. So I would do what? I do my like F number equals my Celsius to Fahrenheit on my C on my T, right? And then I would say print. Okay. I create something. This is called tuple. Tuple has two data. So your temperature in Celsius and your temperature in what? In a Fahrenheit. So this is called tuple. So when two data put in together inside a parenthesis, this is called tuple.
Okay.
So if you think about it, just like X and Y, you have X and Y, and each point you are writing like this. So it's a tuple, 2D data, or 3D data, 4D data. Is that okay? It's called tuple. Okay. So this tuple actually, the T will print out by F format. F will also be printed out by format. So that actually is a 14-point format. Is that okay?
Okay, so 这个 percentage.
Percentage only means that this number will go to here, this number will go to here.
这个是这什么前后的意思。
Yeah, actually this one is only like you insert T to F, insert this one to the second F.
Okay.
So if you don't have this percentage, you won't. It just print some data. That's fine.
Okay.
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 So that's actually clean this one. And then that's the one. Okay. So you got this, right? But actually not aligned well, right? So basically what I want to do is like, I will like to do is like 6.2 format. What is 6.2 format? 6.2 format is like
number
so basically you have the
前面的那个 number
precision.
Okay.
So for example, you have 80
0
whatever, right? I'll pick 2 digits
2 0
for the precision for P, right?
Okay.
So decimal one more 4, 5, 6. So maximum 6 digits for here. So basically it will be aligned. So the data will be aligned by each one will print out 6 digits. And then 2 after the decimal point.
So the F.
So this one actually is aligned by this.
So the 6.2 F, the F is mean format.
Mean floating point.
Oh, okay. Oh, it means floating point. So it's not the F variable. It's the okay.
It's not an F variable. It's actually the a floating point.
Okay.
Data type. So this is a specification for format. Okay. So
you just type. I saw you just type percentage and then D. So the D is mean. What's the meaning of the
decimal? The integers. Yeah, D is decimal.
Oh, okay.
D is decimal for integers. So before this, actually we can actually print now, right? So you want to have the if you want to have the Celsius format, you can do U2103, okay, and then paste U2109, okay, and let's see what this is. These are 2 Unicode, okay. These are 2 Unicode.
U2103.
Yeah, 2103 is the Unicode for the Celsius symbol.
Oh.
So your Chinese later Unicode.
Unicode. Okay.
It's this degree Celsius symbol.
Okay. File format.
Okay.
Okay.
So you get this one. And actually you can also do like Unicode for circled numbers.
Okay.
So you can find a Unicode for all of the symbols.
Okay.
Right?
Okay.
Even this type of whatever.
So the Unicode is for all the computer language?
Yeah, even emoji also has the Unicode. As long as
so Python including the emoji.
Yeah,
Unicode.
as long as you put /u something.
Okay.
So this number is the Unicode. Okay.
Oh, okay.
So after that, because I want to draw a line in between this, right? I can use this print, and then this times 34. Okay. This is different than other language. Python is very powerful.
Times 34.
Yeah.
Oh.
So okay. I get it too long. I dropped to 24.
Oh, okay. Okay, interesting.
It's way better, right? It's way better.
Oh, I see.
Okay?
Okay.
So this simple program is interesting, right? So if you are not happy about this, you can also do like from pilot import start, like something, right? And actually you have this T, right? You have this T, right? So here you can actually do something like y equals this, right? And then over here you say y dot append f, right? So here you say x equals this one called list range 0, 1, 1, 10, 0, 10, right? And then you figure. So you make the range data into a list, and then you say figure, right? So, and because each of the Fahrenheit data got appended to y, right? So right here you can actually do plot your x and y in your color, and then you can do scatter x and y.
Oh, okay.
So you got data here and here, right? Is that okay?
Okay.
Let me take a picture.
Oh, the y point append. The append is means
Y original is empty. So each one I get an F, I add it to Y.
also
Each time I get a each time I get an F, I put it to Y.
okay.
Okay, so I send this one to you. So later you can do self-study with this. Okay.
Okay.
You will know. I'll send you the code, but it's better that you have that to look at. Okay.
Okay.
So this one show you basically show you how you starting from a simple conversion, putting the I/O, even the graphic into it. Plot is like one line, scatter is for those different scatter points. Okay? So we finish that. So that actually, okay, so that actually temperature is a module. Temperature is a module. Test temperature is another module. So for these two modules, we form a program. That's what I'm trying to say. So your test temperature module called your temperature module. So two modules, and then each line is called a statement.
Okay.
Each line is called a statement, and the expression is part of the statement. Say this one right hand side is an expression.
Okay.
This one percentage and with the tuple is an expression. This range of the list is an expression. So if you look at your say if you look at a book, right? English writing book. So your module is somewhat like your chapter, right? And then your book is your program, right? And then in each chapter, in each module, you may have different functions. So the function is somewhat like paragraph. Okay, and then each function will have many statements. So statement somewhat like your sentence.
Mode of function.
Right?
Statement.
And then you have expression on this side. And it's somewhat like your phrase.
Okay.
And then you have ID on this side or variable on this side. It's somewhat like your words.
Mm-hmm.
Is that okay?
Okay.
Comparison, your English article.
Mm-hmm.
Okay, one by one of different levels.
Okay.
That's called your element of the program. Okay.
Mm-hmm.
That's called the elements of your programs.
Elements of your program.
The component of your program.
Mm-hmm.
Okay, so you're basically your statement, whatever function. So you have a name. Each variable has a name. Each function has a name. Those names called identifiers. And every identifier must begin with a letter or underscore. You cannot start with a number. You can only start with a letter or underscore.
Okay.
Okay. And identifier are case sensitive. So CAT, uppercase CAT, and the lowercase CAT are different.
Okay.
Variable.
Okay.
So CAT and the CAT are different.
Uppercase is different.
Yeah. Okay. Next one, name. These are all different and all valid. Okay. All valid. An element of the program, some identifiers are part of the Python itself. These words are called reserved words. For example, and, delete, for, is, raise.
Reserved for, okay.
These are reserved words. You cannot use them. Okay.
Okay.
Some of them you can redefine, but these you cannot redefine. Okay. Expression is a part of speech. So say A equals, so say something like C equals A plus B. This part is an expression. Speech. Okay.
Okay, expression.
Okay, so you basically, this is okay. This is okay. And then element. Then after the expression, you have an operator. You have a plus, minus, star, slash, stars for multiplication, slash for division, double star for is the power.
Okay.
So you say 2 star star 3 means 2 to the power 3. It actually equals 8. So the normal mathematics precedence apply by this. So here it would be, if I calculate it, the first one I'll calculate is this power thing. And then it will be this time. I'm sorry, actually, the next one will be, I'm sorry. The next one should be this division first. I'm sorry, the next one, this one, the parenthesis will be done first. And then divide by 2, and then time division. And then this one, this. And then eventually this. Okay?
Oh, okay. Okay.
Okay, element you can print that. If you have a single print, you change the line. If you have print expression, you will print out one by one. Okay, and then you also have, if you don't want to change line, say here usually just print or print whatever, each will print line. Print the whole line and then change line. You will actually also print a new line like this. If you don't want to print change line, I want to print A, right? I don't want to change line, so you say end equals empty string. This one will just print A, and then the next one you will say print B, then B will be just following. You won't have a change line mark in the between.
Oh, okay.
If you don't want to change line.
Okay.
And all of these print without end equals empty string, you will actually change line.
Oh, okay.
So bare print will print a brand new link, blank line. Okay. So this one 3.4, this one will print out this. And this one print out 3, 4, and then basically this one just print a line. This one is invalid, I think. Okay, so you print out 3 and 4, and then this one, wait for the next time, you print out like this. Okay. This one, the answer is 7. Okay. Is that okay so far, Lisa?
So the print 3, 4 and end equal, it means print next time?
This one is to continue with the next print.
Oh.
But actually, this one will not change line. So actually, you wait until the next one.
I see.
But 7 connected with the 3 and 4.
Oh, okay.
So a program may include several modules, and then module may call some standard library. So right here, actually, let's go back to our program. Here I import the temperature and with this whole thing, right? So let me actually try another one called test temperature 2. Okay, and I copy my test temperature. And then put my test temperature 2, right? If I actually don't import temperature, everything from temperature, just import the temperature. Okay, so this one actually is not okay now. I need to put temperature dot.
Oh, okay.
Okay, then it's fine.
Oh.
Is that okay?
Okay.
If you don't import everything, you will need that.
Oh, if I don't import everything, so I need to
put the name of
identify which one I need.
Which module I call from.
Okay.
Which module I call from. Okay, you need to identify which module. The next one is the assignment statement. Assignment statement is not hard. You actually have an equal sign. You assign a value from expression to the variable. Okay. And then you assign this data from the right to the left to the Fahrenheit. Okay, these are assignments. So I think this is easy. So if you originally have x equal 10, you plus 1 and assign back to x, it will become 11. It will become 11 for your x. Okay, so this one is called increment. This one is important. Yeah. So basically, you in Python model actually you don't actually multiply the same data. It actually will point to a new data called 11 object. In Python, not in other language, but this is in Python.
Okay.
Python actually it doesn't actually multiply the 10. Actually, it will assign a new value called 11 and allow x to point it to. This one is special for Python because Python is a pure object-oriented environment. So the input portion I talk about, you can use the eval to either integer or double, and maybe sometimes you can also eval to string if it doesn't follow an integer format or the floating point format. It will be eval to string.
Oh, okay.
And sometimes if it actually is a true or false symbol, you will be eval to the Boolean data type.
Oh.
Depending on what string actually you put in. So eval is actually more powerful, but somehow confusing right now, so it's not recommended.
Okay.
In the near future, in the recent time, but it actually is written by a lot of people. Okay. And then you can assign the input and then assign to some variable. Okay. And be aware the function is very powerful and potentially dangerous. So that's why recently some people don't recommend. I'm fine with it. So it allows the Python interpreter to evaluate it. Someone know Python could employ this ability and whatever. Okay.
The last page, it says the function is very powerful and potentially dangerous.
Yeah.
But what's mean the potentially dangerous? Why?
Because if you have a wrong input format, the program may be dead.
Oh.
The program may be dead. So for example, if I don't want to see my program say, I don't want to see my okay. So for example, if I have I equal integer, right?
Mm.
My program is pretty simple.
Mm-hmm.
In this case, if I enter 3,
mm-hmm.
it will break, right?
Oh, yeah.
But if I actually, let me see. Wait. No.
T?
That's not
I.
That's not correct. If I have an I, it won't break, right? If I put a 3, it won't break.
Okay.
Right? But
yes.
if I enter something called this, right? It won't break, right? It breaks, right? But if I use eval, what would be the result? If I use the result, eval, what would be? It will just let it pass. I'm sorry, it actually is not straight. Let me go one more. It's not, it's a string. So if I actually do 3.5
numbers,
okay, it's actually numbers. So, but this one actually, if it still get in, right? But I need an integer. But if sometimes I actually just need to be strictly as integer, what should I do? I can actually do this. Okay, so here like this, okay.
Try I integer.
Okay, something like this, right? So here, if I do this, wait, no, here I should do
down, false.
So normally you don't allow your system to break down. So right here, if I type garbage, when I print the floating point, it still be error. Only until I hit 10, it goes through.
Yeah.
So this one actually, initially I set my down to be false, right? While not down, I will loop, right? And then if I go to here and I enter an integer, so nothing happened, I go to down equals true and I get out. If my format is wrong, this input cannot be finished, down will not be executed. It will go to the wrong format and enter again. and then loop back to here. Down has still be a false. So this one is called input validation. But if here I change to eval, then floating point will also go through. You know what I'm saying?
Yeah.
So that's why sometimes it's dangerous because it's not checking the right format for us. So sometimes it's called dangerous because it's not. I don't want floating point to go through. I want strict integer, but I cannot stop them to give me the wrong format. So it's called code injection attack. Okay. And assigning input here is like when writing for your own project, this is probably not much of an issue. Yeah, usually it happens when you actually go to a bigger corporate programming. So simultaneous assignment, you can assign several variables at the same time. A, B, C with 1, 2, 3. Okay, that's actually possible. So your program basically. Let me see, is this one. So here I can say A, B, C equals 1, 2, 3. Okay? That's a multiple assignment. And it's quite useful, and it's a good feature in Python language. Makes things much easier to do. Okay? So that's that. That's this one. Simultaneous assignment. Okay. Simultaneous assignment. So I think this one okay.
Yeah.
The next one is definitely low. Definitely low, actually I show you already in the example of the temperature T in a sequence.
Yeah.
Range, right? Range 0 to 100 step by 10. And then I execute the body. So it's similar to other language that you actually write something called for loop. In other language, you have a for integer I equals 0, I less than equal 100, and then I increase. This one is the same with this one for in range 0, 110 by 10. Okay, two are equivalent. So that's fine. That's actually different loop. Different loop means you have a fixed number of the loop iteration to do. Okay, and the second part needs to be a sequence. You need to generate a sequence. So actually you can do for I in and print it, you will print out 0, 1, 2, 3. For R number in this, and you print out this. Okay. So range 10 is from 0 to 9. Okay. Now including 10.
This is okay. This is just means.
This just means this.
A series.
Okay. Later I'll explain what is this.
Okay.
It's similar to array in other language. Similar to array in other language. Okay. So different loop is the for loop. So you check the condition, update, and then go back to check the condition. Feature value project. For example, we have a bank account, okay, and then we have a certain interest associated with it, and then every let's say it's a compound interest. So how much money I will have 10 years later, okay? So initially I have a principal and interest rate. Every year I grew my money by say 1% or 2%, okay? So that's the spec. So user enter the initial amount of investment, and then enter the APR, annual percentage rate, okay?
Yeah.
And your program get the principal and the APR, and then you need to output. 10 years later you will be. And every year you need to have the principal times 1 plus percentage. Right? And then you do it 10 times. So this is a pseudocode. Put now introduction, input the principal, input the rate, and then do 10 times output.
Okay.
So implementation, you utilize Python to write this, right? And then this pseudocode.
Yeah.
And the real code is like this. You actually print out a program, whatever, and then get the principal value, get the rate, and then each year you update by, say, certain percentage.
Yeah, okay.
And only for 10 years. That's it. And then you get a result. Okay? So
okay.
Feature value 1. But let's look at the feature value 1 program. And then should be fine. I need to. Okay.
Okay.
$1,000. 0.01. Is that okay?
Yeah.
Okay.
Oh, I saw someone write a code in at the end of the loop. They say return. So what's the meaning of the return?
Return is return for function. It's not loop. It's for function. So something like this temperature.
Okay. Yeah.
Yeah, we return something.
Return. Define.
So you write by a function called nothing, right? I call a function called nothing, and here I say return. Usually this return is return some value, so actually I should be able to do something like this. So usually whatever function I define should be define f of x, right? And then define this, and then y equals x plus 2. So I will return y, right? So outside y should be f of x.
Okay.
Right? But here, this one do nothing means I just run nothing, and the program will terminate. Program will do nothing.
Okay.
Terminate. And this one, I will return this value. So I will have my Celsius equal my Fahrenheit to Celsius value, which is 32 or something. And that value will return to C. Is that okay?
Okay. Return to C. Okay.
So return has two features. One is to break a function. The other feature is to return some value to the caller.
Okay.
Okay?
Okay.
Okay, so that's it for the day, and then wish you have more practice, and then next time we'll go to chapter 3.
Yeah. Okay. So what's the homework? Assign homework for me.
You go to your chapter
2.
Finish all of the multiple choice and the true and false section. Let me put another textbook.
You mean 2? Chapter 2 exercise?
Yeah.
Okay.
So you go to your textbook.
Yeah, I'm here. So chapter 2 exercise, multiple choice. Oh, okay, I saw it.
So you do at the end of the chapter. So let's go to chapter 3 and then go back.
Okay.
So here you have the starting from the exercise. So you also need to do chapter 1, the true and false, everything.
Oh, okay.
Okay, and then multiple choice, everything. Discussion you can do or not doing it is fine. And after that, the program exercise pick at least 3 for me. Whatever one you want to do.
Okay. You mean one of the those
3 from the programming exercise, at least 3.
Oh, okay. Okay.
So for some children, actually, some kids, like middle school kids, I show you. So it's a student lesson. So he has a unit for problem, right? So actually he sent me like this, and then the red one that says
okay. Okay.
Okay, something like that. And then some of programs is wrote. Okay, it just sent to me, and I may modify for him.
Okay.
So, but you better tell me which in the program, tell me which chapter and what exercise you wrote.
Okay.
Is that okay?
Okay.
And then I will correct it. Okay.
Okay.
Send it to me. Okay, and usually I may be more available on the morning of the Wednesday or Thursday. Okay.
Okay. Okay.
Every week, sometime like that. So let's assume that 1 week a time, and then maybe sometime next week, Monday or Tuesday.
Okay, Wednesday or Thursday morning.
Yeah.
Okay.
Is that okay?
Yeah, it's good.
And then you have a whole weekend on Monday, Tuesday.
Yeah, I can do my homework. Yeah.
Okay.
Okay. Thank you so much today.
Thank you. Bye now.
Bye.